Issam's mathematics videos. First of all, I would like to take the opportunity to wish you all a happy Eid with best wishes. We hope the end of the epidemic soon, so stay at home and stay safe. So let's begin. So in this video, we will be explaining mathematics function problems exactly. We will take care of the exponential function exactly. So what we have, so this is the exam of 2018. We consider the numerical function defined by fx equal x squared minus x multiplied by exponential minus x plus x. So as we can see, we have an exponential function. So before we begin, we have to know that exponential functions are defined for each x in the interval minus infinite plus infinite. Okay? We don't have problem with exponential x. So the x can be any number from this interval, minus infinite or plus infinite. Okay? So the question we have here is to calculate the limit which x goes to plus infinite to this function. Okay? So the limit when x goes to plus infinite of f dx. First of all, we have some remarkable limits for exponential that we all know. We can do them here. Limits x plus infinite, exponential x is equal to plus infinite. This is properties from the lessons. We have the limit when x goes to minus infinite of exponential x equals 0. Okay? We also have the limit when x goes to minus infinite x exponential x equals 0. Alright? For this one, we can generalize x exponent r, which r is a normal number, like from n, like 1, 2, 3, 4, 5, 6. So we have this start here, which means all the numbers, like the normal numbers, except 0. So this one, for example, we might have limit x goes to minus infinite, x squares to exponential x. It's always equal 0. So as x exponent 3 exponential x is equal 0, and etc. Okay? So this one is generalized. We start from x exponent 1. Okay? We also have the limit when x goes to plus infinite, the exponential x divided by x exponent r, which are always from this interval, like normal numbers. It's equal to plus infinite. And the last one we have limit when x goes to 0, exponential x plus 1 divided by x is equal to 1. So we have 5 limits, remarkable limits, 1, 2, 3, 4, 5, that we have to know. And those limits will help us to solve any function problems. Okay? Good. So let's do this one. We have here this function. So first of all, when we calculate the limits, what we do first is this one. We have here a polynomial function. So the answer of this one is plus infinite, because we will take care just only for the x squared 2. So it's plus infinite. All right, this one. So replace the x with plus infinite. We will have minus and plus infinite, which is exponential minus infinite, which is 0 actually from this property. All right. So we have 0 multiply by the plus infinite, which is problem. We call it undefined form. We cannot have plus infinite multiplied by 0, so it's a problem. All right? So we have to do another way. So we have to figure out. So what we can do here, limit x goes to plus infinite, is we will develop this multiplication. We have here x squared multiplied by exponential minus x. So x squared multiplied by exponential minus x minus x multiplied by exponential minus x plus x. All right? So we all good about this. Okay. What we know also about the exponents with minus degree, it can turn to, for example, if we have a exponent minus 2, it turns to its inverse, which is 1 divided by a squared 2. So the minus degree turned into a plus degree, but we inverse the formula. All right? So the same thing we will do with the exponential x. This one is equal to limit x goes to plus infinite, x squared 2 divided by exponential x. So as we can see, the exponential minus x turned into 1 divided by exponential x. Multiplied by x squared, we have this one. All right? Same for this. Minus x divided by exponential x plus x. All right? So here we stop and we look. Then we compare with the remarkable limits that we have. We have here x squared divided by exponential x and x divided by exponential x. Do we have a limit here that resemble any of this? We can see limits when x goes to plus infinite, exponential x divided by x squared or exponents r. So it kindly looks like this one, but it's different. This is actually the inverse of this remarkable limits. Okay, look at this. We have limits. We can do like this. Like we can do the proof. We stop here and we do like this. We know that limit when x goes to plus infinite, exponential x over x is equal to plus infinite. All right? So this is the remarkable limit. So this one is the inverse of this one. Are we okay with that? Look at this. We can do so. Limit when x over plus infinite of x divided by exponential x is equal to what? To limit when x goes to plus infinite of 1 divided by exponential x over x. All right? So we do the inverse. So just to explain to the corrector exactly what we have. So the inverse of this one is 1 over exponential over x. So we have like fraction here and fraction here. Look, just to be sure, this one, I will erase this one. We have like fraction divided by another fraction. We have it's equal to 1 multiplied by the inverse of this one. It's x divided by exponential x, which is actually this one. Alright? So just to be clear, I explain it that way, but I won't write it on my paper. Okay? So I already said that we know that the limit of exponential x over x is equal plus infinite. So what's gonna be the 1 over plus infinite? It's actually equals to 0. We have this in mathematics. So it's equals to 0. So this one is 0. So same thing for this one too. Because we all have this property. Exponential x divided by x exponent r. So same thing. Okay? So I will erase this part. To continue the length. So I would say, and same thing for limits when x goes to plus infinite of x squared divided by exponential x is equal to 0. So we have here 0 and this one 0. 0 minus 0 is 0. So we have this. The left one is x. So the limit when x goes to plus infinite of x is plus infinite. So conclusion. The limit when x goes to plus infinite of fx is equal to plus infinite. That's the last answer. And then we can do at the bottom to be more specific, because limit when x goes to plus infinite of x is equal to plus infinite. So this is how we should do. Alright? So I will erase this and then we will work on the limit when x goes to minus infinite. So here the second question we have. Find the limits when x goes to minus infinite of the function fx. So as I said before, whenever we have limits, what we do first, we replace each x with its value, which is minus infinite, in the function. So here what we're gonna do. We have limits of minus infinite of x squared to minus x. It's equal. So this is a polynomial function. Alright? And we have a rule that says whenever we have polynomial function, we take only the biggest term, which means the term that has the biggest exponent. So this one, it's equal to limits when x goes to minus infinite of x squared 2. And pay attention, always when we have x goes to minus infinite or plus infinite. This is a rule. Okay? So this one is going to be equal to minus infinite square 2. Attention please, we don't write this in mathematics. It's not correct. So I'm just explaining. Okay? So we have minus infinite square 2. So the square or the exponent is an even number. Whenever we have even number with minus degree, it turns to plus. So it's going to be plus infinite. Alright? So this limit, it's going to be plus infinite. Okay? So as I said, we don't write this. I'm just explaining. Okay, good. We have also the limits when x goes to minus of exponential minus x. What we can do normally is to replace its exponential minus infinite, which is equal to exponential plus infinite, which is plus infinite. Because we have a rule that says whenever limits when x goes to plus infinite of exponential x, it's equal to plus infinite. So this is what I do. And we don't write this in mathematics, okay? So I'm just explaining to you. All right. So we have here plus infinite. Okay? As I said, it's plus infinite. So, plus infinite multiplied by plus infinite. It's gonna be plus infinite, of course. Okay? Good. And the last one, it's minus infinite. Okay? Because we replace x with minus infinite. Conclusion, we will have plus infinite minus infinite. That's the last answer. And we have this, it's undefined formula. We cannot say plus infinite minus infinite because we won't know the right answer of this. So it's going to be question mark. Okay? So we have to do something. We have to change in the fraction. Okay? So I was just explaining. So now we will figure out how to solve this limit. Okay? Here we go. So first of all, we will develop the expression. Limits when x goes to minus infinite, x squared 2 exponential minus x, minus x exponential minus x, plus x. Alright? Good. What we can do again, we will multiply. We remark that we have a common factor, which is x multiplied by exponential minus x. So this is a common factor. We will multiply by this. Equal limit when x goes to minus infinite, x multiplied by exponential minus x, multiply by x. Because this one multiplied by this one, we will have this. Minus 1. Alright? And for this one, it's going to be plus 1 divided by exponential minus x. And we will verify, look, exponential minus x multiplied by x multiplied by 1 divided by exponential minus x. This one it goes because we have the multiplication and it stays x. So we're correct. Alright? So we're correct. Good. So as the last step, what we can do here is that we have here a minus degree on our exponent. So as I said, whenever we have minus degree, it turns to its inverse and we change the degree or the sign. So it's gonna be limits when x goes to minus infinite of x divided by exponential x multiplied by x minus 1 plus. And same thing will happen to this expression. We have here 1 divided by exponential minus x. When it turns to its inverse, it's going to be exponential x. Alright, good. So here we will know the answer. So we're going to do like this. And we will do the proof. We will explain. Because limits when x goes to minus infinite of x equal to minus infinite. And we know that we have in the remarkable rules the limits when x goes to minus infinite of exponential x, it's equal to 0. Alright? And to be more specific, we all know that the exponential x it's superior strictly than 0. It's all, the exponential x, it's positive. So the exact answer of this, it's plus, it's 0 plus. And we all know that minus infinite divided by 0 plus, it's minus infinite. So as a conclusion here we do, then limit when x goes to minus infinite of x divided by exponential x, it's equal to minus infinite. So then we have this part right here. Also, the limits when x goes to minus infinite of x minus 1, it's equal. So this is same thing. It's a polynomial function. We take the biggest term, which has the big exponent. So it's going to be the limit of x, which is minus infinite. And we have this one. The limit when x goes to minus infinite of exponential x, it's 0. So 0 plus minus infinite, it's going to be minus infinite. So we will say, so the limit when x goes to minus infinite, x minus 1 plus exponential x, it's equal to minus infinite. So as a conclusion, so we have this is minus infinite, and we prove that this one too is minus infinite. Then minus infinite multiplied by minus infinite, it's going to be plus infinite. So that's my answer. All right, I hope that you understand, and wish you best of luck, and see you in another video.